Hey everyone, Azim here. We are in the chapter starting on slide 32. We are talking about connective tissue. We just finished talking about epithelial tissue, the characteristics, the different types, special types like the different types of exocrine glands. We're saving endocrine for later, but that's also a type of epithelial tissue. We're going over another tissue type, so it's the second one, connective tissue. The other two are muscle and nervous tissue. We'll go over those later. We saw how epithelial tissue, those cells are really tightly packed together. They're always facing a lumen. Those are some major characteristics of them, and they're not vascular. They are avascular. Compare that to connective tissue. Connective tissue is not as packed together. The cells are more spaced apart. And the cells, so if the cells are not directly next to each other, what is in between them? The hallmark characteristic of connective tissue is the fact that they have something in between the cells termed extracellular matrix. It's outside of the cell. Extra means outside. Extracellular, and it's outside of the side of the cell, and matrix refers to a network of something. So you've got a network of stuff outside of the cell. We've talked about interstitial fluid. That's just liquid and tiny molecules or ions dissolved into that liquid. Extracellular matrix is that plus solid stuff. It could be solid stuff. We'll talk about special protein fibers, could be minerals like in bone, but it could be a number of things, and that's what makes each type of connective tissue unique. We'll talk about the different types of extracellular matrix. The term for the fluid of the extracellular matrix, the term given is ground substance, so it's basically the interstitial fluid of the extracellular matrix. And then there's special proteins. We'll go over certain protein types coming up. Connective tissue extracellular matrix can vary from fluid, blood. The fluid of blood is plasma, and plasma is the extracellular matrix of blood. Dermis is it's the intermediate layer of your skin, and it's made of different connective tissues that are not quite liquid, but they're not quite solid either. They're somewhere in between, so it's a mix. Fat also kind of mixed. There's stuff in between fat cells. Bone, on the other hand, is very solid. Bone is very solid. So all of these are examples of connective tissues, and they vary in terms of what the extracellular is made of. And that also dictates its function. Blood, by being very liquidy, by having a fluid extracellular matrix, can transport things, while bone, by having a solid extracellular matrix, is great for support and protection. So that's one major characteristic that all connective tissues have, a special kind of extracellular matrix. I also said that while epithelial tissue is avascular, because you don't want to easily bleed out, connective tissue is highly vascular, it has lots of blood vessels. This is what receives blood supply. The picture down here on the diagram show, let's look at the actual histology here. It shows cells. Look at how spaced out the cells are. All those things I circled in blue are cells. They're all spaced out. Everything that I'm going to color in pink, these are protein fibers in this particular example. Those are protein fibers. Those are part of the extracellular matrix. Those are not cells. They are protein fibers, like lots and lots of them packed together. That's why you can see it under this microscope. We'll take a look at what cells make up these connective tissues, and also, very importantly, what's in between the cells that make up these connective tissues. Before we do that, I want to talk about where all these tissues came from. Remember embryonic germ layers? Most connective tissues come from mesoderm. Comes from mesoderm. The term for the embryonic cells that eventually lead to all other connective tissues, the term for them are mesenchyme cells. Remember the CH in this class usually comes with a hard K sound, mesenchyme. Mesenchyme cells have the potential to give rise to all other connective tissues. Pictured here on the left side, these are mesenchyme cells. Each one of these individual masses, dark staining things, are cells. You'll also notice how they have like little branches and things in between them. Those are collagen fibers. That's the British way of spelling it. Those are collagen fibers. Collagen is a protein. We'll see that this is one example of a protein that we can find in the extracellular matrix. Maybe you've heard of collagen before in some skincare products. It is something you find in your in your mesenchyme and in other connective tissues. But mesenchyme can become all the different types. It has not yet fully differentiated. It's slightly differentiated. It's only going to become connective tissue, and it can become any one of those connective tissues. Now, there's many different types of connective tissues. Let's go over the basic categories right now. Before we do that, let's talk about some of the basic functions, and we'll go over the basic categories. In general, connective tissue is there to support your body, to protect your body, to transport things around, to connect and hold things together. To physically hold things together, you like fascia. This is stuff, it's tissue that surrounds muscles, surrounds bones, surrounds certain organs. It holds things together. Tendons hold muscle to bone, your skeletal muscle to bone. So like my biceps brachii connecting to my, let's connect to my scapula. It's connecting through a tendon. Or a ligament is bone to bone. That's connective tissue from bone to bone. In this picture, you can see it. This part right here is tendon. Here's muscle. That's one example of what connective tissue can do. It can support, surround, and connect. Fat is great for energy storage. Fat is also good for cushion and connection, but it's also great for energy storage. So there's another unique function. In some of our bones, and many of our bones, in the center, we have red bone marrow. And red bone marrow is the location for where red blood cells and other blood cells, I should say all blood cells, red blood cells, white blood cells, where your blood cells are made. So red bone marrow is a site for blood formation. Oh, and pictured here, a single one of these cells is an adipocyte. You store fat inside of that big circle. We'll take a look at more examples coming up. More examples of adipose and these other things. Connective tissue can serve as a framework. It can, like your skeleton, made of bone and cartilage. Picture here is bone, actually. You can see how the cells are spaced out, and then there's stuff in between. It's very hard and supportive. Blood and lymph. If you're not sure what lymph is quite yet, we'll learn how it's a special type of interstitial fluid. But blood and lymph, they help transport fluids, help transport nutrients, waste throughout your entire body. Shown here is blood. And you can see how blood cells are all separated from each other. In between the blood cells, that's where you have plasma. Leukocytes, also found in blood, help defend you from microorganisms. So while we think of connective tissue traditionally as something that holds your body together, like how tendons hold muscles to bone, and that is one really important thing that connective tissues can do, there's clearly a whole host of other things that connective tissues can do. They can transport, they can defend, they can provide a framework. They do a lot to help support the body in different ways. So how can we categorize these three types? Or how can we categorize these types of connective tissues? We can divide it into three types. Let me go from right to left. Supporting connective tissues, these are very solid. very, very solid connective tissues. It has a solid extracellular matrix. Bone is a great example of a supporting connective tissue where you have mineral in the extracellular matrix. Cartilage, we'll talk about the special proteins that make that up. We'll talk about these two later, but these are examples of supporting connective tissues. Fluid connective tissues are ones with fluid in the extracellular matrix, exclusively fluid in the extracellular matrix. Lymph and blood are your two fluid connective tissues. We'll also talk about this later. As you can see, there's a lot of different connective tissues. What I want to focus on in this lesson is connective tissue proper. Just add the word proper after connective tissue. Connective tissue proper. There are 6 types of connective tissue proper, divided based on how dense or loose their extracellular matrix is. So we're going to look at this today. The 3 loose connective tissues proper and the 3 dense connective tissues proper. Our first connective tissue proper that we're going over, oh, it's a loose one. It is adipose. Adipose. Let's take a look at the histology first, and then we'll talk about what it is. Take a look at the picture over here on the right side, top right. A single cell has a nucleus, plasma membrane, which I'm tracing over in black. Where I drew that dot for the nucleus, all the other organelles are there too. They're all just shoved to the side. The remaining space of this cell, which I'm shading in yellow, that's adipose storage, fat storage. Another word for fat is adipose. Your adipose tissue are storage areas for fat. Fat is great for cushioning. Fat is great for insulation. Fat is great for energy storage. It does all these things. It does look like these cells are kind of close to each other. Let me trace the other cells. Like here's another cell, here's another cell. But this fits under the category of loose because in between the cells, which you can't really see with the histology, but you'll have to believe me, in between the cells, you have protein fibers in the extracellular matrix. What I'm coloring here in green, these are, and also in this illustration here on the side, these are collagen fibers. Collagen is a type of protein found in the extracellular matrix, and it's creating this loose open framework. Collagen fibers are proteins that are large, they're long, they're straight, like what we see here, relatively straight, large, long, straight, and they don't really branch. The benefit of collagen is that it's tough yet flexible. Think about maybe like a really wobbly tree. A wobbly tree, it can bend a lot in the wind, but it's pretty hard to break. So it's tough yet flexible. Why do we need this? If adipose is going to be a good place for cushion, if it's going to be serving as cushion in places that's deep to our skin, the deepest part of our skin, the superficial part of your skin is called cutaneous membrane. The deepest part is your adipose. If we're going to create some cushion, we need some spring back and flexibility, some toughness and flexibility. Adipose has collagen in its extracellular matrix. It can provide that cushion and flexibility. So to recap, adipose cells, adipocytes, That's the term for an adipose cell, adipocyte, is a big circular cell. The nucleus and organelles are pushed to one side, and the rest of the cell is for storage of adipose. There's collagen in between the cells, though you can't see it with a light microscope. Our second example of a loose connective tissue proper is reticular tissue. Reticular tissue, we've seen that word before, reticular. Reticular means that it's another word for network of something. Lots of words that mean a network of something. Reticular, plexus. Reticular tissue doesn't have collagen fibers. It has reticular fibers. What are reticular fibers? Look at the histology over here. Reticular fibers are these dark branching protein fibers. Dark branching protein fibers. More in this photomicrograph down here, dark branching protein fibers. They are stiffer than collagen and therefore more supportive. They provide a supporting framework. Reticular fibers are not for flexibility. Reticular fibers are for providing support, providing meshwork to hold things in place. Reticular tissue helps hold things in place. You can find this in organs that are plush yet firm. Hopefully you've seen the fetal pig videos or dissected it yourself or gotten to the cadaver already, and you can poke these organs and feel the difference. If you poke the stomach, for instance, it's super flimsy. It just kind of pokes right in because it's the wall is super flexible. But say you poke the liver or poke the spleen, there's a bit of give to it. It's soft, but it gives back. That's because it's made of reticular tissue. You find that in places like liver, kidney, spleen, lymph nodes, bone marrow. So for these organs, it provides a framework. It holds all kinds of cells in protecting it. But the cells that help maintain, or let me back up, the cells that create this reticular fiber network in the first place are fibroblasts. Fibro, because they're producing fibers. The word blast, that root word blast, refers to cells that are more younger, more young, immature. They're for building. Blasts are for building. They build these reticular fibers or whatever fibers are producing, in this case, reticular fibers. Fibroblasts are for building the fibers. Once the cells have matured and now you've got a whole network of fibers around you, a whole extracellular matrix around you, these are now called fibrocytes. And that's what we see here. When you see a bunch of cells already in place, when you see all the fibers already in place, you have fibrocytes. So fibrocytes are the mature ones. They help maintain the fibers. Protein doesn't last forever, so you have to keep maintaining it. Some proteins break down, so you got to make new ones. That's what fibrocytes do. This is a loose connective tissue. You can see how spaced out the fibrocytes are. You can see how spaced out, well, sorry, not just how spaced out the fibrocytes are, you can see how spaced out the reticular fibers are. The reticular fibers aren't all right next to each other. There's branching, and so therefore there's space between them. By having space between them, by having rigid reticular fibers, that provides a framework for these organs that need framework for cells and other processes going on in them. Our third loose fiber, loose connective tissue proper, is areolar connective tissue. The word areola means space. So maybe you know the word areola as a space around your nipple. That is the areolar region of your thoracic region. But areolar tissue just means it's a very spacious tissue. It's pretty loose. What's unique about areolar connective tissue is that it has collagen in its extracellular matrix. It has reticular fibers in its extracellular matrix, and it has elastic fibers. This is our third fiber type. This is also a protein. As the name suggests, elastic fibers are very wavy. They also branch. And because of this, they can stretch and recoil just like a rubber band. They're very elastic. If you take a look at this picture, I believe this one will show it better actually. Do you see all these dark or wavy lines going this way and this way? Here, here, here. Those are all elastic fibers. You can find elastic fibers, you can find reticular fibers, you can find collagen, all in the same slide here. Highlighted, here's collagen, this dark line that goes across. We'll do that again. There's that dark line, and then reticular fibers are the dark branching ones here. It has all three fibers. The fibers are spread apart, so this is loose. The purpose is that by having all three fibers, it does a little bit of everything. It's a little bit of flexibility, it's a little bit of rigidity, a little bit of framework. And since everything's spaced out, it's just kind of like your jack of all trades type of cushion. It's cushioned yet firm. It's somewhere in between. It's great for supporting, it's great for cushioning, while allowing some movement. You can find areolar connective tissue deep to all epithelium. Areolar connective tissue is deep to all epithelium. All the epithelium that we saw previously, if you looked just deep to it, I've said that there's connective tissue here, it's always areolar, always. It's just a great base layer of connective tissue, just deep to the epithelium. The pictures you see here are showing smeared areolar connective tissue. When we get to histology, I'll show you what areolar connective tissue looks like in a section of tissue that hasn't been smeared. Smearing it allows you to see the fibers better. That's why it's been done here. So when we look at it in tissue, we won't be able to see all the individual fibers. Those were loose connective tissues. We're getting to our first dense connective tissue proper. Let's just look at the histology before we even go over the name. Look at this histology. You can see cells. I'm going to color the cells in green. Those are nuclei, and therefore these are cells. And then everything else, which I'm going to color in blue, everything else, all of this are proteins in the extracellular matrix. Super, super, super dense, packed together. What you'll notice is that these fibers, they are collagen fibers. These fibers are packed together and they all go in the same direction. They're packed together and they all go in the same direction. Since they all go in the same direction, the word we give is regular and it's dense. So the full name is dense regular connective tissue. Since all the fibers are in the same direction, it provides really firm attachment. It's really strong in that direction. Dense regular connective tissue is really strong in that direction. If you take a look at my screen, I have a paintbrush right here. The fibers, the hairs of this paintbrush are going vertically. So if I pull like this, it's super strong. But if I pull the other way, you can break it really easily. Your ligaments, your tendons are really strong in one direction, they're not strong in the other direction. If you ever torn a ligament like I have, like I've twisted my knee and torn a ligament, the twisting is in the other direction. It's in the orthogonal horizontal direction. So that's why it can break in that way. But this way, it's much stronger. There's a limit for everything, but it's much stronger in longitudinally. So dense regular connective tissue provides firm attachment for muscles and bones. Tendons are muscle to bone, ligaments are bone to bone. There is, what we see there is collagen fibers. There's also elastic fibers, but you can't really see it. So you just again, have to believe me. There's collagen and elastic fibers in the extracellular matrix. The cells you see here are still called fibrocytes, and they were once fibroblasts. That was true for reticular. I don't know if I said that earlier, but that's true for the reticular connective tissue and the areolar connective tissue. You have fibrocytes that were once fibroblasts. The only exception for these connective tissues proper is adipose. You just have adipocytes. Now, the downside, as I mentioned before, let me go back. The downside of dense regular is that while it's strong in one direction, it's not strong in the orthogonal direction, the perpendicular direction. So we need a tissue that can provide strength in many directions. So rather than having all the fibers go in one way, what if we just had fibers going every which way? That is called dense irregular. Dense irregular has collagen fibers and elastic fibers, excuse me. Some are this way, some are coming out at us. They're going every single direction. Now, because they're going in many different directions, it's not going to be as strong as dense regular, but you're getting some multi-directional resistance. I want you to remember, for any of these tissues, for really any design, there's always a trade-off. There's no such thing as a perfect design. There's always a trade-off. The trade-off for dense regular is that you're only strong in one direction. Dense irregular, you solve that. You're strong in many directions, but now you're not as strong in any direction. It's a trade-off. We find dense irregular in, we're going to learn about all the layers of skin, but it's the intermediate layer of skin. It's called the dermis. You've got areolar, there's a superficial connective tissue, and then you've got dense irregular, and then adipose. So dense irregular is providing this tough multi-directional force, lets your skin have some malleability. Your skin over time will wrinkle, completely normal. Our cells just don't regenerate proteins as easily. The proteins that don't regenerate as much are these collagen and elastic fibers in our dense irregular connective tissue, and you start forming wrinkles. You can also find this in places like your esophagus and blood vessels to prevent overexpansion, providing a little bit of a framework. Once again, the cells that you see here, those are they start out as fibroblasts and then they become fibrocytes. Fibroblasts build the extracellular matrix, fibrocytes maintain it. I should point out, now that we've gotten this far and we have, I think, one more connective tissue, how are these cells producing these proteins? These fibroblasts, let me draw a fibroblast out here. If this is a fibroblast, fibroblasts are producing protein through that whole process we discussed before. Ribosomes synthesize a protein, process in the rough endoplasmic reticulum, sort and ship in the Golgi, and then you get a vesicle full of the protein released by exocytosis. And now you're releasing proteins into the extracellular matrix by exocytosis. And that you see so much of them here because a lot of protein has been released and they're all binding together, creating this huge network of protein in the extracellular matrix. It takes time, but our body does it. All right, we've talked about dense regular, dense irregular, and our last connective tissue type is elastic tissue. Elastic tissue is a dense connective tissue proper. Look at how tightly packed these fibers are. It's those same elastic fibers that we saw in areolar connective tissue. You see how squiggly these elastic fibers are, providing a lot of recoil. They do mostly go in the same direction when we look at them here. We find them, for example, a good example of where we'll see these are in the walls of blood vessels. They can also be found outside of the lungs or the lining of the lungs, so that when your lungs expand, it can come back to its original shape. Once again, produced by fibroblasts, maintained by fibrocytes. But yeah, elastic tissue, it's great for recoil, flexibility, comes back to its original shape. Once again, as you age, this tends to not heal as easily. Things get less elastic. So your blood vessels, as you age, generally get harder, and that can lead to increased blood pressure, something that we just have to watch out as we get older. Now, this is a good time for us to look at the histology of what we just saw. So I'm going to switch over to the YouTube videos. I guess you're on YouTube right now, but the other videos in our histology playlist. This is the mesenchyme and connective tissue proper histology. Here, this is, well, you see a bunch of debris, that's just from the microscope, but you can see stuff in the background. What's colored in pink. That's our tissue sample. Let's go closer. This is 40x. This is 100x. Oh, and let me back up. What we see here, this is an embryo. And a slice of an embryo. All right, here's 400x. These cells that you see here, cell, they're spaced out. They're not right next to each other. And they're kind of branchy. They have stuff in between them. This is mesenchyme. This is our embryonic connective tissue. This is mesenchyme. It can become any type of connective tissue. Look for cells with light branches coming off of all of them. They're spaced out. There's a lot of cells here. That is mesenchyme. This is 40x. It's hard to see exactly what we're looking at, so we're going to need to go closer. This is 100x. We can start to see little circles here, but a lot of white space. Here is 400x. The darker dots you see here, that's the nucleus. So what I just colored in there, that's a nucleus. And the whole cell is what comes and wraps around like that. This is an adipocyte. So this is adipose, connective tissue. There is collagen in between these cells, like it's hard to see all of them, but where it gets darker around the edges, that's collagen. That's where you would find collagen in the extracellular matrix. This is 100x, I believe. This is 100x. You can see all those little dots. Those little dots are cells, nuclei of cells. Here is 400x. Now, I'll give you a hint. This is a smear of tissue. If you look back through my histology playlist, you'll see how to prepare different types of tissues. One way to prepare tissue is to just take a slice of it and then put it on the microscope. Another way is to take that tissue, smear it, and then put it on the microscope. This is smeared, and smearing lets you see things that would normally be in different planes all on the same same plane. So now we can see these fibers a lot better. If you look at this fiber right here, look at how wavy it is. That's elastic fiber. Look at the darker, broader fibers in the background. They're like these dark, broad pink ones. That's collagen. And then the ones that are also dark but more defined and branched are reticular fibers. The only one that has all three is areolar connective tissue. This is a smear of areolar connective tissue. Let me show you what areolar connective tissue looks like when it's not smeared. I'm going to clear this and we'll see. Let me actually go to this epithelium video. We are at 10:35 in the epithelium video. Transition a little. Whoop. All right, here is 400X. If you remember, hope you do, what type of epithelial tissue are we looking at here? This is transitional. You can see the cells are all different shapes and there's no real perfect layering. But down here, this connective tissue, we see that there are fibrocytes. And then there's some fibers here that you can't really make out what it is. When it looks pretty plain and boring like this and mostly clearish, and the cells are spaced out, and it's right just deep to epithelium, it is always areolar. This is areolar connective tissue, not smeared from a slice of tissue. We'll go to another example of areolar coming up, but here is one great example of areolar connective tissue. Always deep to any epithelial tissue. Our next one is reticular. What we have here, what's pictured here at 40X, this is a lymph node. You can feel some of your lymph nodes pretty easily. The ones right by your neck, just lateral here. They're hard, yet squishy. They're firm, yet squishy. It's because they have, well, one major reason is because they have reticular connective tissue, providing a framework. This lymph node has been stained for reticular fibers. I'm going to get closer. You can see the dark fibers, though, all this dark stuff going on back over here. Not these circles, but these dark branchy things. This is 40X. Here is 400X. The dark branchy fibers are reticular fibers. Dark branchy fibers are reticular fibers. This picture, already at 40X, you can see that fibers are all going in one direction and they're really packed together. It's really dense. If we go closer, at 400X, you can see some fibrocytes spaced out from one another. They're not exactly next to each other. And then all the fibers, these dark fibers that you see here, they're broad and straight. These broad, straight fibers are collagen fibers. This is dense, regular found in tendons and ligaments. I believe this is taken from a tendon. Dense, regular connective tissue. Here is, I believe we're at 100x right now, but this is skin. You can see the epithelium right here. See the flakiness? We're in skin and you see flaky layers at the top. This is keratinized stratified squamous epithelium. Keratinized stratified squamous epithelium. Remember what I said? What type of connective tissue do we have just deep to epithelium? Do you see this layer right here? It's a little bit different from the line where I'm below the line that I'm making and above the line. This range right here. It's kind of light, kind of boring looking. This is areolar. Areolar connective tissue. And then deep to that, you can see all kinds of collagen fibers going every which way. This is dense, irregular. If you're curious, we've been using the word dermis. Dermis is these two layers combined, areolar and dense irregular. But we'll get to that later. Dense irregular connective tissue, one place you can find it is in this part of the skin. Let's go closer so we can see it better. This is 400x. Look at how some of the collagen looks longer, looks round, looks diagonal. It's because they're all in different, they're all coming in different directions. So when you take a slice of it, you get them in different faces. You get different face slices. Dense irregular provides multi-directional force resistance in the skin, surrounding blood vessels, surrounding the esophagus. Here is our last connective tissue. We are at 100x. We're looking at a blood vessel. So here's the lumen of a blood vessel. So there's actually epithelial tissue here. Right, sorry. So here we have the lumen. But then we've got this really dark layer in between. And if you look closely, you can see that there's fibers going mostly in one direction. So let's go closer in this really large blood vessel. Let's take a look at what's in the middle. All right, 400x. This is the wall of a blood vessel. If you're familiar with the aorta, this is the middle of the aorta. You can see these dark squiggly lines. Dark squiggly lines in the middle here. Those are elastic fibers. This is elastic tissue. Elastic tissue can be found. One good example where you can find elastic tissue is in the walls of large blood vessels. And, well, not capillaries, just the other blood vessels. We'll get to that later, but you can find a high concentration of them in large blood vessels. All right, those are your connective tissues proper plus mesenchyme. I hope this was helpful. Please let me know if you have any questions. Leave questions and comments in the discussion. Don't forget to answer the questions that are throughout here. And yeah, let me know. Talk to y'all later. And one more, next video, the last one for this chapter, will be on body membranes. That'll be the next one.